All right. Thanks for the introduction and also picking up my play of words on content is king. I heard that for some time as well. So join me now for about 20 minutes on AR. I think the previous speaker about VR and robots and AI was really fantastic. Now it's a little bit more on substantial matters of AR. Let's put it that way. And I mean, the title already kind of gives it away. We will be talking about context, and I think this is one of the most essential parts of any AR experience and any AR application out there. Just a few words about myself. My name is Philipp. I'm working for the company Wikitude. I've been doing this for 7 years. We're based in Salzburg, Austria. I have a strong product management background and currently act as the CTO, meaning I oversee product and technology. Just 2 days ago, we had this 10-year anniversary of this iconic device, not as iconic as the first iPhone, but the first commercial Android phone, the T-Mobile G1, was as influential and as essential to us as the iPhone was to the industry. It was the first device that brought the necessary sensors in a mass market device that we could do AR. And if you look very closely, you see an app icon that looks like a palm tree. That was the very first app icon of the application Wikitude. As you can see, also Web and Walk. Obviously, this is a T-Mobile device. This was pre-installed. Our application was pre-installed on the T-Mobile G1s, on the very first Android devices. And that's where our journey for AR began. Fast forward nearly 10 years, our company is providing an AR platform, serving more than 100,000 developers out there. More than 25,000 applications have been developed with the Wikitude SDK, and we are an independent company working on and providing AR tools. Some of our clients from the world range from various businesses. This is more like to show how broadly AR and AR applications already have been distributed. This reaches from consumer brands, industry, telecommunication providers. So AR seems to strike not only just one particular use case, but touch on use cases that are very broadly set. How do we differentiate from others? What is the Wikitude AR? What is the Wikitude way? And we have 3 points. Our toolkits work cross-platform, so you can create AR experiences with the Wikitude toolchain that work on iOS, Android, and Windows devices. Our platform can be easily integrated into enterprise environment or existing IT environments without the need to deploy yet another IT silo or bring another toolchain into your IT environment. And we think about AR very holistically. The Wikitude SDK has a broad set of technologies included. It's not just solving one particular niche or one particular use case, but we see AR as a very holistic approach and try to provide as many possible tools in our toolkit that you can choose from and use for your application. AR, VR, MR, XR, so many Rs, but I think there is a particular difference and a particular point between VR and also AR applications. I like this organization, the Virtuality Continuum from Milgram, who put that up in mid-90s, where on the one side we have reality, on the left-hand side he draws reality, on the right-hand side we draw virtuality. So the real thing, the real world versus 100% virtual content. And anything in between he called mixed reality. Coming from the real side or the reality side, if we add virtual content or digital content, we call it AR, augmented reality. If you come from the virtual side, we call it augmented virtuality, a term that no one is using. Microsoft then did us a favor and called mixed reality everything, starting from reality to virtual reality for whatever reason. At least Google and Apple are calling AR, and that's the term we also stick to. But there is one particular difference, I think, that is separating VR and AR. And Matt Misniks from 60AI, a company out of Silicon Valley, particularly in the machine learning area for depth recognition, he cited there's no point building an AR app unless it interacts with the physical world in some way. And I couldn't agree more. I think any AR app, any AR experience that doesn't interact with the physical world, with your surrounding in some way, in some meaningful way, I wouldn't call it a waste of time, but you probably should think whether AR is the right way to do it. And here I have an example which I think is actually a disconnect from reality. That was the introduction of ARKit by Apple 1.5 years ago at WWDC. And they showed this game on top of a desktop, which didn't interact at all with the surrounding or with reality. And by far, I'm kind of want to tell you that we are all smarter than Apple and want to bash Apple, but I don't think that this is really the potential that AR can have if you show a game on a regular desktop that does not in any way obey or interact with this desktop and disk table. So the magic word here, and you could guess it, is context. And as the Oxford Dictionary defines it, the context is a set of circumstances or facts that surround a particular event or situation. This is a pretty broad explanation and a pretty broad definition. But I'm okay with that. I think the reality every one of us is experiencing and is living in is broad. Our contexts differ, and they're very different from what we are in every day and every second. And I think creating AR experiences that work with the context of the user is a similar paradigm shift as VR was for game developers. When game developers approach VR, the fact that you cannot dictate what the user is currently seeing, but you need to add cues and you need to add hints where the user in VR is actually exploring the scene. I think this is a similar paradigm shift here for creating AR experiences that obey and work with the context of a user. So how do we deduct context? How can we work with context in an AR application? And there are several technologies currently available that give us some part of your context that we can work with. And that's what I want to explore with you now for the next 10 minutes. One part, GeoAR, geolocation AR. The fact that I can place content onto geo-coordinates or geo-coded points of interest, like in this example. Ice Age 4 promotion in the Netherlands back in 2013. The company put virtual nuts throughout the Netherlands, and the challenge was to go to those places and collect those nuts. Sounds similar to Pokemon Go. In a way it is, but this already happened like 4 years prior to that. So we can work with geolocation. We can deduct context and information from the position of the user. We know where he's roughly looking at. We know what the user is seeing, so we can inject information in there. Is this a lot of context? No, but it's a little bit. What else can we deduct, or what else can AR technology currently deduct for us? Image recognition. We can kind of understand which kind of images and which kind of flat images the user is currently seeing. MediaMarkt has been using this to augment their leaflets. Catalog providers use this to create a more interactive form of their catalog. Time magazine has put out a special edition of their magazine honoring Obama, 8 years of Obama, with a companion app. So once you hovered over certain images in this print edition, you could see the speech or you could see this moment on video. Very like the Harry Potter newspaper that got to life. So images, recognizing images is another form of getting context from the user where the user currently is. Another technology that has several names, markerless tracking, instant tracking, positional tracking, VIO, and so on, is the ability that we can track the motion of a certain device. So if the device is moving, however the device and the person is moving with the device, we can track and we can understand that. That in itself does not yet give us a lot of context. But we can ask the user that he gives us context. Like in the example in the middle, home furniture and home planning, where we put virtual furnitures into your home place. We ask the user that he should put that furniture into his place, wherever he wants to have it. But that we get the context. Like the furniture is placed where you want to have it and it stays there. So in a way, we're getting context out of this as well. Of course, we're not only working with images, we're not just working with objects. We also want to, with instant tracking, we also want to work with objects. So object recognition and also scene recognition is something we can deduct information. Very similar to image recognition because we have a reference there, we have a reference image, a reference object, or a reference scene. The difference being objects, I'm kind of more thinking of tabletop-sized objects that we can go around. Scenes, I'm thinking more of entire rooms, church portals, or other things. How could this look like? This is one of our videos, most recent videos. So we have a digital representation of this toy car, this remote control toy car, and we're adding some virtual flames to that. I apologize for the bad driving skills. That was me, actually. But that is something we can work on. So the context is the car itself. The software understands where this car is from any angle in any motion. So we can put some additional content on top of that. Or let it be scene recognition, where we can detect and visualize or precisely localize for entire scenes and entire rooms. A word you might have been hearing, in my opinion, a buzzword is AR Cloud, which summarizes several technology aspects. On one hand, very precise visual localization. Precise, I mean sub-millimeter accuracy compared to GPS localization, which usually goes in between 2 to 4 meters. It's the fact that you can store content persistently on certain elements and that you can share and work that cross-platform. So two of us can perceive the same scenery and register in the same scenery. What I mean with that is shown in this example. Here we go. Which are actually two demos from ours with our toolkit. So in all its examples, we have a sharing component. We have two persons registering in the very same context or in the very same spatial area. In the very first example, that you could see this was the room, the living room scenario. The living room was mapped, and both iOS and Android devices registered in the same scene. In the game scenery, the yellow castle that you could see in the background was the common denominator, so both were registering towards that. And as you saw, the quality of the localization is highly accurate. Otherwise, AR would not work, right? If you cannot come to the point that your illusion is believable or your illusion is credible, you will not make this rich experience. Looking at an AR, VR, mixed reality system from a very high level perspective, we can basically separate it into 4 components that interact with each other. A sensing component, so a set of sensors that is sensing the surrounding, that is kind of giving information to the computing unit that takes this information, computes position, tries to understand the surrounding, giving that to a visualization engine or a rendering engine, and then feeding that to some sort of projection mechanism, either being a smartphone display or smart glasses. And if we look for each of those components, what kind of is still ahead, you will see there's a lot more to come that could give us contextual information to make AR experiences richer. And I will not go through all of them, but most research and most progress currently is done in the 3rd column from the right-hand side, or the middle column, easier. So I split computing into 2 parts. One computing part is detection of localizations of pose estimation and pose information, getting to know how the device is moving. We're pretty far there. But the middle column shows kind of the efforts around scene understanding. So the AR device getting to know more information about the surrounding. That's something we need. That's the contextual information that we need. What do we currently can do? As I said, we can recognize predefined images, we can recognize predefined objects, we can work with some sort of plane detection, but that's nearly it. What is interesting, I think, is, and a lot of projects we're seeing is the ability to detect or create an entire mesh, an entire 3D object or 3D sculpture of your current surrounding. So meshing in real time, that's a big topic. And then going towards semantic understanding of the scene, or the ability to know what material we're actually looking at. For a game, it matters whether this is a solid surface or whether this is a very soft surface in order to calculate how a ball, for example, bounces off. On the visualization side, as the title says, it's kind of our job to enable you to create the perfect illusion. And such an illusion must be fitting into your AR scene. And when it comes to rendering, we have great rendering engines out there, Unity, Unreal Engine. They produce high quality content, but they are not fit for the task to put content somewhere here where we don't know anything about the current light situation and light environment. That is an unsolved problem in the industry, detecting light situations for any kind of given point. The light situation here is very, very different from you, right? Placing content here would require a very different rendering than putting it into the auditorium. And as an Austrian, I cannot leave without having Arnold on my slide deck as well, because in a way, this still image from Terminator 1 shows actually a quite good summary of what I think where we're heading towards. Not having killing machines, I'm not saying that, but if you look here, what kind of the machine knows about this scene, that's quite a lot. It's not, for example, nothing we can do at the moment. It can detect the motorcycle in the middle. It can also detect there is a motorcycle not ahead of it, so it knows depth information about all of those objects. You see the dashed lines? That means kind of something is occluded by that. We have semantic, the machine has semantical understanding of this motorcycle. It knows the type, it knows additional information. Those are things that we might have in the future as well, right? A very good understanding of the scene linked up to a semantical database to understand what we can work with. And kind of getting to the point why I think context matters. Why is contextual information actually beneficial? I think I haven't answered that. Let's look at the very same application, Google Maps, in its desktop version, its mobile version, and its an AR version. I think what should be noted here as well is AR itself is not a use case. AR can make existing services more useful, more practical, more tangible, but AR itself, the technology, is not a product. So desktop, mobile, and AR version of Google Maps. Let's look at it from a kind of information density perspective. How much information can I show at the same time when using those versions? Obviously, the desktop version, you can show a lot of information, you have a lot of options. You give the users a lot of options to click, beautifully separated, perfect UX. On mobile, this is already a lot more limited. Smaller map, just a few options. The AR version of Google Maps is basically just showing directions, nothing else. However, coming back to the context we can work in, that is obviously a lot different. On a desktop version, I don't have a lot of context. If I know who the user is and roughly in which region is, that's already good. In AR, we know where the user is, we know exactly what the user is looking at, maybe we can detect some items, so the context we can work with and present that information is a lot higher. So that is kind of my theorem here that I've been running around for years, and my hypothesis that adding those two up, at the end, the AR version will give more relevance to the user, and the information we can present and the service we can present is more relevant compared to others. We'll see whether this proves true or not. I mean, that's my working hypothesis, but I think that's actually why AR matters and why AR experiences will be adopted and accepted by the users. So much about context that we as platform providers give in your hands to create AR experiences that hopefully matter and are more relevant than other services. Thank you.